All right. Let's do 7.2 systems. Ooh. All right. I was like, that's really bright. All right. So everybody should have the notes in front of them. Maybe, possibly. Perfect. Okay. So in 7.1, we created systems. In 7.2, it's going to be nicer because the equations are given to you, and you guys have graphed these for most of this course, so it should be pretty easy. So you just need to know that a solution of a system, the solution is where the two lines intersect. So that's just a fancy name for where they cross. It's not an intercept. An intercept's where it crosses an axis. An intersect is where the two lines cross each other. And you need to give it as a coordinate pair. So that's it. So you just need to remember that the solution is where the two lines intersect, and you have to give it as a coordinate pair as x, y. So pretty straightforward, sort of, kind of. We do this all the time, like in grade 12, we do this quite a bit. Okay, so if I were to ask what's the solution, okay, what are the equations of these lines? So that's kind of where we are in chapter 6. We were working on equations of lines. So we should be able to create the equations of lines. So let's call this line 1, and we'll call this one line 2. A little dot above it. So we're going to create the equation for line 1 first. So, what's wrong, Steve? Left is line 1, right is line 2. Zoom in a little bit. That's a little bit better for you. Okay, so let's look at line 1. This line right here. First thing I'm going to do is I'm going to say, is there a nice y-intercept? Is there a nice y-intercept? Yes. So it's nice, it's 1. So there's my y-intercept. So I'm going to use y-intercept, or sorry, slope-intercept form because I don't have to do slope point. It's nice and easy. It's already figured out there. So we know that this point is at 0 and 1. We know our y-intercept is at 1. What do we need now?
Our slope.
We need our slope. So what's the slope of line 1? Maybe I'll write it like this.
Negative p over 2.
Negative 1.
So we definitely all agree that it should be a negative slope, right? Because it's falling to the right. So we all agree that it should be a negative slope. So I'm going to count. So I'm going down 1, 2, 3, 4. So I'm down 4, and I'm going over 1, 2, 3, 4 to the right. Can I reduce that? So my slope for line 1 is negative 1. Okay, good. So this is your chapter 6, right? So chapter 6, chapter 7, we're all dealing with these lines, so we should be able to do this. So if I'm going to put it into slope-intercept form, that's y equals mx plus b. That's the format I'm going to put it in. So I know that y is equal to negative 1x, and we said our intercept was at a positive 1. So it's going to be plus 1. So that's the equation for line 1. Okay, can you do this for line 2? Does it have a nice y-intercept?
Yeah.
Nice, good. Okay, there we go. So what's the slope for line 2? And is this slope positive or negative? Positive, because it's rising to the right. Anybody? 5 over 5. So we're going up, well, let's go 1, 2, 3, 4, 5. So we went 5 right, so that's my denominator. And then we're going 1, 2, 3, 4, 5, and we went 5 up. So that's going to be a positive 1. So my equation is going to be y equals positive 1x, and my intercept was at a positive 5, so add 5. Do I need to write that 1 there? No. I don't need to. I'm going to leave it there, but I didn't need to write it. Ooh, my pen's running out. So that's the equation for line 2. Okay, so what are the coordinates of the point of intersection? So that's where those 2 lines cross. So I'm looking for that coordinate pair right there. -2, +3. And that's the solution of the system. That's the solution of the system right there. It's just where the lines cross. That's the solution. Now tomorrow and Wednesday, we're going to actually do this algebraically without the pretty picture. So we're going to start easy with the pretty pictures, and then we're going to move into algebraically, which isn't harder. It's I like doing it better. It's just who I am. Okay, we're going to solve the system. So this one you actually have to graph it first. Mm-hmm.
If you do the exam, will you be able to see how the mistakes you did?
If you want to come back in and check, but my grade 12s will be writing the next day, but if you want to pop in the afternoon of the Tuesday, you could. Because I need to mark them Tuesday afternoon, right? So I won't have answers for you like your Monday afternoon, but you can come in Tuesday afternoon. Yeah. You don't get to keep it, but you can take a look at it.
But I just think it's how the areas that you can improve more and stuff.
What do I tell you need to do? Slow down, pay attention to the details. That's the areas you need to improve upon. Okay, I got 2 equations. So this one's going to be line 1, and this one will be line 2. All right, so do you guys want to put them into slope-intercept, or do you want to graph them in this form, which is standard form? Graph them in this, okay.
No,
you're crazy.
You do it in slope-intercept form. That's what my formula comes to do this.
Okay, doesn't matter to me. No, because we need more than 1 point, right? When we graph a line, we need more than 1 point. So I'm going to change them into y-intercept because I think that's the nicest one to graph. So y-intercept means you're going to have y equals and then everything else on the other side. So I'm going to move this x to the other side, so I got to subtract x from both sides. So I'm going to have y equals -x plus 8. So what's my slope for that one? Over? Nice. So maybe I'll put that information over here. So my slope for this one, see it's just a -x right now, but my slope for this one is going to be -1 over +1. And that's good because it's telling me I'm going 1 down and 1 to the right. Where's my y-intercept? Where's my y-intercept? +8. So it's going to cross the y-axis at 8. Let's rearrange this one here. So I might do this one I might scooch over to this area here. So I have 3x minus 2y equals 14. So I want to get the y by itself, so I'm going to move the 3x. So I'd have 3x plus 14. And I like to put my x's first, but you don't have to if you don't want to. I just like it because that's the format of y equals mx plus b. And so then I'm going to go ahead and I'm going to divide. I want to get rid of the 2. So the operation between the -2 and the y is a multiply, so I need to break that up. So I'm going to divide by -2, and I have to divide by -2 by every term on this side. So that will leave me with just y here. And then I've got a -3 over a -2. How am I going to write it? +3 over +2x. And then 14 divided by -2 is going to be -7. So we know that this one has a slope of 3 over 2, so we're going up 3, and we're going to the right 2, and we know it's going to cross the y-axis at -7. Okay? So rearranging it into y-intercept is kind of nice. You could do a table of values if you're more comfortable with that. They just might not be super friendly numbers. Okay, so now I got to actually put some increments on here. So let me grab a different pen. I think every second one I'm going to go up by. So every second one I'm going up by an increment on my x-axis. What do my y-axis has to go to?
+8 and -7.
Right. So I know that this has to go at least up to 8. And if I count these out, I've got 1, 2, 3, 4, 5, 6, 7, 8 is right there. So I'm probably going to go up by 1s. I'm only going to label every second one just because, well, it's tiny.
If you have 2 points on the graph, can you just draw a line?
You can, but in this situation where we're looking for points of intersection, I wouldn't do just 2 points. I do a few more than that. Okay? All right, so I'm going to graph line 1 in red. I'm going to graph line 1 in red. So the first point, I'm going to plot. How am I going to deal with this? What am I going to do first? Start at the intercept. So I'm going to plot my 8 on the y-axis. And then I'm going to follow the slope. The slope's the road map to get to your next point. So we're going to go down 1, over 1. Down 1, over 1. Now, if you guys just use 3 here, that might not give us our point of intersection, so you might want to do a few other points. Excuse me. Down 1, over 1.
Wait, is our, or what do you call it, point of interest, is it +6 over +2?
What are we talking about? I don't know what you're referring to.
Our solution.
Okay, we haven't even graphed the second line, bud. So I don't know. So I'm going to go ahead and I'm going to connect these with a ruler. Ladies and gentlemen, what I'm noticing, like when I marked your last test, I noticed that very few people are putting arrows on either end. Like we could keep going on. The arrows indicate that it goes on forever. So you don't want to have your line just between these 2 points. You want to extend it past that, and you want to put arrows on it to indicate that it does continue on. We just don't have the time in our lives to keep graphing. So this equation is y equals -x plus 8. That's what that line represents. So I'm just going to make sure I label it because I'm putting more than one graph on a single graph. Putting more than one line on a single graph. So now I'm going to go ahead and graph this equation in green. And so what's my first point? -7. So I'm going to drop that point on first. And then I'm going to use this as a road map. So we're going up 3 and we're going to the right 2. So 1, 2, 3, 1, 2. So there's that point. I'm going to go 1, 2, 3, 1, 2. There's that point. 1, 2, 3. 1, 2. Oh, look at that. So do you guys see the point of intersection? It's a point that's shared by both of the lines. So again, I'm going to just continue my lines a little bit beyond, and I'm going to put arrows on them. So that's that graph. So where is our solution here, folks?
Our solution is plus 6 over plus 2.
Not plus 6 over plus 2. Remember that it's written as a coordinate pair. So we would all agree that this is where they cross, right? So my solution is 6, because we do the x first, and then the y. So that one's my x, that one's my y. So we give it as a coordinate pair. So you need to state what the solution is. You can't just circle it, you need to actually state what it is. Circling it just helps, but I need to know you understand that the solution is where the two lines cross. Okay, Rahat, do you think you can put your phone away? Thanks, bud. No, Arun doesn't need it. You can put it on the desk beside you. You'll help him? That's very kind of you. Okay. Oh, sorry. I didn't check. It's a true story. Are we good to flip, Jonah? Okay, so this one is 7.1, a little bit of 7.1, and a little bit of 7.2. So you got to create the system here, and then you're going to graph it. Okay. So I got some information here. I have $5. Sorry, to visit the head smashed in Buffalo Jump Interpretive Center near Fort Macleod, Alberta, the admission is $5 for a student and $9 for an adult. That's exciting. Okay, but what about them? Okay, so you got the first equation. So in 1 hour, 32 people came through. So, and then it says, sorry, I'm just trying to find a highlighter here. Then it said that and a total of $180 in admission fees was collected. Okay, slow down. So Steve had given us S plus A equals 32, and I would 100% agree with you, Steve, that that's our first question, or our first equation. But we need to define those variables. So we're going to say let S equal the number of student tickets. Sometimes it's easier to create the equations and then define the variables. Sorry. Let S equal the number of student tickets. And what does A equal? If S is the number of student tickets, what other kind of tickets do we have? Adult tickets, right? So this is the number of
the fees. $180 equals to 5S plus 9A, right?
Yeah, so that's the second equation. So this first equation dealt with quantity, or how many tickets we sold. So that talks about how many tickets we sold. The next one, the next equation that we're at is about the money. How much money we collected. So we know that it's $5 for every student ticket. So if I sold 10 student tickets, I would have made $50. Okay? And if I sold 10 adult tickets, how much money would I have made? $90. Isn't that exciting? And we know we made a total of $180 in that hour. So you've just created the system. So that's 7.1. What we just did there was 7.1. So if you haven't done your lessons from 7.1 yet, that was it. So if you haven't done your homework. Okay, now we're going to graph it. So if we look at the graph I gave you down here, what is A? A is on the y-axis and S is on the x-axis. So remember how in the last equation we set them all equal to y, so it was easier to see? We can graph it that way. So what we can do is equation 1, we said that A was our y, so we're going to set it equal to A. So I have S plus A equals 32. So that's on our y-axis, so I'm just going to label that. So I know that's what I'm trying to set it equal to. So we're going to minus S from both sides. So A equals a negative S plus 32. So what's my y-intercept? What's my A-intercept, I guess?
Oh my god!
And what's my slope?
Wait, your slope is minus 1, and then your intercept is plus 32.
Okay, good job. Okay, let's see if you guys can do this one. Can you rearrange this one to equal A? So see if you can do it on your own. So you're going to get A on one side. You're going to get A on one side and everything else on the other.
What?
Set the equation equal to A.
Oh. We just found out how many kids there are.
Didn't we find out how many adults there are?
Yes? Wait. This doesn't make sense.
Okay, so that's what I got when I rearranged it. So do you guys like the booklets better or the individual lessons? Booklets? Okay. Good to know. All right. So I'm hoping that everybody got those two equations. So let's go ahead and graph that first equation. I'm going to graph that one in red. So the first thing I'm going to do is I'm going to put the y-intercept, which is 32. And then my slope is?
-1.
Down 1, right 1. But do you guys notice that these go by 2s? And these go by 2s? Could I go down to over 2? Would that be the same thing?
Sure.
Does -2 over 2 equal -1 over 2? No, 1 over 1? Are those the same things? Yeah? So it's just going to make it easier because then I can go down box by box. And I'm not going halfway.
Does a cat equal a skeleton?
Oh my goodness.
4 and positive 4?
I don't know what you're talking about.
Because, like, you know, you see our increments are going going by force, right?
Okay, I've got another question for you. Can I have a negative A value?
No.
What does A represent?
Adults?
It's the number of adult tickets. Can I have a negative number of tickets? No. So that's why when you look at this one, it's only positives. It only has positive values here. Oh my goodness. Okay, that was a lot of dots for me to draw on here. So now I'm going to connect them. And am I going to put arrows on this one? No, because what did we just decide? You can't have parts. Ooh, you know what? Should I have connected those?
No.
Oh, I should not have connected those. Why shouldn't I have connected those?
It's discrete data.
What does that mean, Rahat?
It means you're not supposed to connect them.
But what does that mean? What does discrete data
You
mean?
can't have a hand of the kid only going to the concert.
True story. We don't give out half tickets. Whew. Oh, I can't remember when we talked about that. That was way back in like chapter 4 or something.
This course is easy.
Okay. All right, so we got some discrete data there. Okay, now I'm going to graph the second one in purple. Where is the y-intercept on the second equation?
Isn't that the x?
At positive 20.
Isn't that the x? Shh. I know we need don't. So I accepted in our class.
This 20 doesn't change. Why would this become the x-intercept, Rahat?
Because it's, oh, never mind.
Right? Like it's still the a-intercept. So still 20, but now this is going to go down 5. Oh my goodness, down 5 and over 9. Holy Hannah. Okay, so we're going to have some odd dots going on here. So we're going to go down 2, down 4, down halfway, and we're going to go across 4, 8, and then part way. So the next dot is in there. I got to get rid of these little dots that I put along the way.
Wait, it's negative 509, is that the sum?
Yep. That's what I mean. It's like a weird one. So you got to go down 5, and then I got to go to the right 9. So it's like halfway in between 8 and 10. So my point's right there. So I'm at 15, so I'm going to go down to, ooh, that's good, 10. And then if I'm at 9 and I got to go another 9, I'm going to be at 18. So I'm going to be right there. Okay. All right, that one's a nice dot. So I got to go down. Okay, so I got to go down 5. So 1, 2, halfway. And then 18 plus 9 is 27. Oh, look at that. I'm on that line. So now we got to figure that one out.
Wait, are you on the line or just really close to the line?
No, I'm on it.
Wait, how?
Well, because you can go by ones, right? Can you not go down 1? Each one of my red dots is going down by 2.
Right.
So there's an extra dot in between each one of these. It's a lot of dots, ladies and gentlemen. Whew. All right, so where is the solution for this? Right here. So what's the coordinate pair at that point?
175.
Is there anything we can do it without using a pretty picture?
Yep. We'll do that tomorrow. It's so much nicer with algebra. You're going to love it. So what does that mean? This represents S, and this represents A. So how many tickets did we sell? 27. What kind of tickets? 27 student. 27 student. And that means we sold 5 adult tickets. And 27 plus 5 is 32. So we know that works. And then if we were to put it into this equation way back up here, would it work here? So would 5 times 27 plus 9 times 5 equal 180?
1 second.
Okay. I can do this one. What's 5 times 27?
125 plus 45, which is the equivalent of 180. It actually works. Though.
It does. So we know that it works in both equations, so that's a good answer. So we can check it once we think we know what our answer is. So that here is a check. Do you guys need the graph or the math? So tomorrow, ladies and gentlemen, you're going to get a video. I'm going to be downstairs in the grad assembly. So you guys are going to get a video on solving it algebraically tomorrow.
We gotta solve.
Yeah.
How is algebra?
You need to, we don't have time. You need to know it.
There's a bunch of blank days. You're just playing on phones.
Let me come to the grass.
No, you get to go when you're in grade 12.
What happens in the grad? I'm gonna make that video.
Talk about grad stuff.
Like,
Like they're going to do the valedictorians speeches and stuff like that. We're going to talk about grad and like coming to grad and getting ready and elementary visits and getting your grad gowns and fun stuff like that and safe grad. And,
elementary visits, state grad.
Are you gonna watch the videos now?
And what does what do you call it, valedictorian do?
They do a speech at graduation.
Nothing else.
Nope. They lead the grad class in. So they're the first people to walk in and they're the first person to walk out. They lead the grads in the grad cap toss. And they represent the grad class at graduation.
I mean, Nicole gave me a few cookies, so I hope she wins.
Okay. All right, 7.1, you're going to do this. In 2006, the population of Canada was 31,612,897. The population of the eastern provinces was 12 million more than the population of the territories and the western provinces. Whew. Okay, that's exciting. It is. So I'm going to define my two variables. So let E equal the population of the eastern provinces. My other one's going to be population of the western provinces. I guess it's western and territories.
Rest of the population, right?
Okay. Yeah. Hey.
You're not recording?
I am recording.
Okay, okay.
Okay. All right. So we know in total our population was 31 million and a bit. 31 and a half, we'll say. So we know that east plus west equals 31,612,897. because that's the total population. Okay, so then the next sentence says the population of the eastern provinces was 12 million more than the territories in the western provinces. So who has more, east or west?
East.
East is the bigger. So we're going to say east is equal to the west plus 12,369,487. So there's my two equations. That's equation 1, that's equation 2. Okay. If I said go ahead and graph this, how happy would you be? Not happy.
My dad graphs these sort of stuff.
Nice. Does he do it by hand?
No.
No.
He uses Excel.
Yeah, the computer does it. And why wouldn't we want to graph this by hand? The numbers are way too big. So in some areas, we wouldn't want to actually graph that because like I can do it in a computer and it would be so much nicer and it will be really exact. If we were to do it by hand, it would be a giant graph and it would be way too many numbers. So this is why we wouldn't want to graph that one. And I wouldn't expect you to graph it.
7.2 times Japanese in